you all today, and now I'm going to tell you about EPAM and some career opportunities within our company. I will try to be short. So, my name is Camila. I'm working as a people experience specialist. Simply saying, I'm event manager, organizing events like this and some others for our external and internal auditory. Who are we? EPAM. We are consultant, designers, engineers, architects, and trainers who enable our clients to be competitive and distributive in the marketplace through innovative technology solutions, while helping them to successfully navigate through multiple waves of technology and social changes. EPAM was founded in USA by the grade school classmates Arkady Dobkin and Leo Losner. They started a software engineer service company with just 3 developers and some small office in a single client. Since then, the company has grown tremendously, and now EPAM is a global IT company with more than 60,000 specialists around the world and offices in more than 55 plus countries and regions. So why people choose us? Why EPAM? First, we provide limitless opportunities to grow for smart, self-motivated, proactive, and collaborative individuals. On our learning platform, any EPAMer can find different trainings, mentoring programs, and comprehensive learning models to enhance both hard and soft skills. With us, you will be able to work with the world-changing technologies and become a part of global IT community of industry top professionals. Unfortunately, I can't share you with the list of our clients, but I have signed NDA, but most of them you can find on the Forbes Global 2000. Our unique culture helps to create equal professional environment for everyone, and our employees can manage their work schedule and work remotely. Let's talk about EPAM Uzbekistan. This year, our local office turned 6 years. In February, we celebrated this. And now we have 2 offices in Tashkent, here on Makhtumkuli in IT Park, and also in the Aybek Street. During the time, we can be proud of a list of achievements, such as rapid growth in a number of employees. In the beginning, there was like 5 employees, including our country head, Rinat Aksamov, and now there is more than 500 of us all around Uzbekistan. Many interesting corporate events were held, many communities were created, and much more. We also launched EPAM Campus, which for many was the beginning of career in EPAM. Let me talk about EPAM Campus. So, in EPAM Campus, we have more than 150,000 course participants, 30 plus years of experience with our experts, more than 2,000 experienced trainers, and 30 plus training directions. You can see the directions on the list. There is Java, Net, Python, like everything for everyone. Students' learning journey. They divide into 3. You can start with trading of basic level, studying at the EPAM laboratory, and implementing job-ready skills. We also have digital library of articles. There are materials for self-study, soft English skill courses for soft English and improving your English. There's technology overviews and some success stories for your motivation and inspiration. You can explore our events on our social medias, and there is the QRs for social media on Instagram, Telegram, and YouTube. Thank you. That's all from my side.
My name is Elior, and I'm a lead software engineer at EPAM, and today I'll tell you about the whole reason we gathered here today. It's an MJC school event, and I'm just going to tell you about MJC school. I'll tell you more about the school itself, and let's take a look at the agenda. I'll start with the intro. The course is split into stages, so we'll discuss every stage in detail. After that, I'll talk more about the learning process. We'll discuss all the various resources available in MJC. And then for our more experienced colleagues, we're going to discuss about opportunities for mentoring and contribution. Oops. What is MJC School? MJC School is a free of charge, community-based Java school for everyone, regardless of age, occupants, or residents. MJC School is an educational environment for engineers, students, and Java enthusiasts to deliver top-notch discipline standards and create knowledge-sharing structure. Let's list the attributes of MJC School. Let's list the attributes of MJC School. It is open source, completely free for anyone. It's online and self-paced. It revolves around communities where people are eager to develop themselves and help others. It has production mentoring in latter stages to prepare for your first Java job, and it provides professional opportunities because the top students are going to be considered for the Java jobs in EPAM. Let's take a look at what you receive as an MJC student. You will get an access to a large variety of knowledge base with different learning materials, with everything you need to learn Java from scratch up to a production standard developer. You will be able to practice all your knowledge with code tasks that have automatic checks enabled for the comfort of your self-progress. As students, you will receive support needed to progress throughout the course from experts in the field, and you will get assigned a personal mentor in the latter stages of the course, and all that completely for free. Let us go through each stage one by one. Everything starts with stage 0. This is for complete beginners, fundamentals, where you will get an introduction into computer science, learn what Java and its components are, get familiar with basic Java syntaxes, get into OOP fundamentals, and after this stage, you'll already be able to write some simple console applications. We proceed to stage 1, which is Java core, where we will dive more deeply into Java itself, learn the collections, input-output, stream API, concurrency, and you will gain way more experience and be able to write a little more complex Java applications. Next stage will be all about web. It includes servlets, versioning, build tools, introduction to SQL, and you will be capable of writing some basic web applications in Java. The next stage, the stage number 3, will introduce you into the world of modern frameworks like Spring and Hibernate. You will learn more advanced architecture and how to write Java applications by utilizing modern frameworks. And the last stage, finally, is stage 4 for enterprise preparation. Here you will learn the rest of the important topics required to get your first enterprise job in Java. This stage, you will get a personal mentor assigned to you. Here you will discover such concepts as CI/CD, advanced REST, Spring Boot. You will introduce security, authorization, authentication into your applications, and you will learn how to deploy your applications into AWS. After reviewing the stages, let's go over and talk about the learning process, how it goes in our school. The most important, crucial part of it is communication. All of it happens in Discord channel. We have different mentees talking to each other. Here, the communication with the mentors happen. You have different channels to discuss different stages. And for example, the stage 4, where you get assigned a personal mentor, also you contact him through Discord channel, main communication method. We also have a Telegram channel, which we post a lot of various Java interesting facts, questions, quizzes, and I strongly encourage you to join it, not to skip an event like that in the future. All the learning material is also placed in GitHub with all the source code of tasks too. It's publicly available. Here's the link to GitHub itself, but also feel free to wait till the end where I'm going to show all the links. And they're also available in mjc.school website, which you can access anytime from the QR at this edge. Okay, and this is AutoCode. You will also find the link to this too. This is an EPAM tool to actually execute and automatically verify the success of your task implementation. Let's take a look at one of the example tasks. This is actually the very first task that you have in MJC School. It's extremely simple. You just have to write a console Java code that prints out hello world. But it doesn't stay simple for long. You can see a latter stage. In stage 3, you have a task like that. You have some sort of solution in stage 2 that then you have to migrate to a Spring-based solution and write some CRUD operations. For some of you, it might seem simple, something that you learned some time ago, but MJC School prepares you for everything from scratch completely, and it's an interesting task to get a first introduction into Spring. And you can see it's quite complex, quite interesting too. We also have a YouTube channel, and currently we're streaming this event on YouTube channel, so you can see some previous streams of such events, and also a lot of videos from our experts on different various Java topics that are very well made, very interesting, very much knowledge sharing. And this was everything for students, but we might have some more experienced visitors here. For anyone who's more experienced and want to participate as a mentor, we'll also have that ability too. It's not just for EPAM. MJC is open for everyone. So if you want to become a mentor, that would be great too. We will gladly accept you. And some of the mentor responsibilities would be to understand the current material and work on updating it, for example. So because we have a lot of Java tasks and they need maintenance, they need some updates, some newer versions. As a mentor, you will also assist a lot of students in learning. They have a lot of hiccups in their learning process, and someone who is more experienced helping them would be extremely useful for them. You will check their results for example, stage 4. You will prepare them for production, share your expertise, and potentially conduct light talks where you just gather a bunch of students and you just talk to them about some Java topic, making some kind of a mini tech talk. And for whoever doesn't want to become a mentor, because that's a lot of responsibility, you can just contribute anytime you want. If you have any free time, just go into that Discord chat, look at the questions that students are asking. They will seem basic to you, but they will help you a lot. This whole thing gives you a very good feeling of helping people and actually improves your own knowledge too, because no matter how experienced we are, sometimes by teaching other people, we just find something new every day. You can always update some material. You can record lectures for YouTube. If you're ever curious and you don't have the audience, but you want to talk about some topic, just create a video, send it to us, and we're going to review it and post it on our YouTube, where a lot of other fellow MJC students will be able to learn. And that is all I had about our school. Here are some of the links. You can take a picture of this. You can go to the mjc.school website. If any questions or for opportunities, feel free to reach out from my email. And after this, we're going to proceed with our technical talks. And I encourage you to listen closely and ask some good questions. Whoever asks the best question for each topic is going to receive a small gift. And at the end, we're going to have a quiz also for a gift for the winner. Thank you, everyone. I'm going to give the stage to the next person.
Yeah, hello everyone. Thanks for coming. Well, I'm Asliddin, currently working as a software engineer at EPAM. Once I was a student of MJC school, then I got offer from EPAM. Now I'm working there as a full-time. Yep. So today we are going to talk about Java memory model, and this would be our agenda for today. And first we start with Java virtual machine and some of the different memory structure of Java. Just a second. So then we talk about Java memory model and what kind of problems it solves while writing concurrent Java applications. So at the end, we will have Q&A session. Yeah, so basically most of us are Java engineers, so we write Java codes, and Java virtual machine is a place where our Java code will be executed. Interestingly, JVM does not understand our Java code, and for that, we have compiler which basically turns our Java code into something called bytecode. This is like a series of instruction which JVM understands and process. So yeah, and back then this was one of the key features that made Java very popular because of platform independence that it brings, right? So you write code in Windows operating system, for example, and regarding your OS, that compiled code can be run in other systems as well. So, and this JVM has components. One of them is class loader. Basically, it's responsible for loading that class files into memory, right? And as we just briefly talked, Java has different parts of memory, and here we are referring them as runtime data area. So once we load that class file, so this is the time comes to executing them. So this is the responsibility of execution engine. Sometimes we will need help from outside, for example, running code that is written in other languages such as C or C++. So in that scenarios, we need help from this native method interface and libraries. So now we are going to take a look at different parts of Java memory. And here, quite a few of them, we have stack, heap, method area, PC registers, and native method stack area. Today, we mostly focus on first two. So let's start with heap. Heap is like a shared area where all the objects will be placed into, right? So, and this is like a global, and multiple threads can access objects, right? And so it means that heap is not thread safe. So this would be the responsibility of the developer to actually manage this. And so all the things in heap will be accessed via references. And so, okay, heap also split into different parts, right? So this is we call young generation and old generation. And within young generation, here on the left, we have hidden space and survivor spaces, and old generation, sometimes called tenured space as well. The idea behind this split is to improve garbage collection process. Every time object is created, it will first go to the hidden space, right here, and after some cycle, here in the young generation, we will have minor garbage collection, right? So it will move objects from hidden to survivor spaces, and after some threshold is met, that live objects will be moved to old generation. And here in old generation, we will have less garbage collection compared to the young generation. And so all the unreferenced objects will be cleaned up by garbage collector, right? So here, like in Java, memory is automatically managed. So yeah. Let's continue with stack. This is also known as JVM stack. Like unlike heap, here like every JVM thread creates like a stack, and so here like stack would be per thread. So it means that like it's thread safe, and every like method call within our application creates something called stack frame. So this is for every method call, and these frames are pushed and popped to stack in a LIFO manner, which is like last frame pushed to the stack will be popped first, right? And within this frame, we have this local variables and operand stack, return info, and yeah. So let's put things together. Here we have simple application where we have main method, right? And we have person record with one field, which is name. And following, we have 4 objects, and we are creating list from them. And at the end, we are printing P1. So if we visualize, somehow this kind of picture will come to our mind. Like here, we have stack for thread 1 and frame for the main method, and we have this like variables referencing to the heap. Here you can see. And so, for example, let's set like now all objects are reachable. So when we set P1 to null, for example, like sometimes it can trick that we might assume that reference is gone, but this is not the case because we can still access P1 through the list. And so, and when we actually set these people to null, in that case, all the reference like for P1 and people list is gone. Now it's the job of garbage collector, basically, which reclaims memory from these unused objects. Yep. So what is Java memory model? Well, it's the specification that has a set of rules that helps us, let's say, that solves some of the problems that may arise in concurrent programming, right? And we are going to take a look at some of them in the following slides. To understand it better, like let's start with this picture here, like an example of modern like computer architecture nowadays we might have. Like here we have more than 1 CPUs, and actually these CPUs can also have cores. Like here the point is, you know, 1 CPU is capable of running 1 thread at a time, right? So, and when, for example, we need this, when we need to run jobs simultaneously, we need actually more CPUs than 1. And that those CPUs will have their like registers where it stores its results, right? So within that register, it talks to CPU cache memory, and some of the architecture can have a layer of caches like L1, L2, and basically here just we can assume it's a cache. We read it from it, and so this cache talks to the RAM, which is our main memory. Well, so basically for hardware memory, like there is no difference between stack and heap. At the end, they will be placed into actually RAM, right? And so when, for example, 1 thread works with some part of data, so it loads that data into CPU cache and into registers. And when this, like, we have data in different places of memory, so problems start to arise. And one of them is visibility of thread updates to shared objects. Here we can see that in RAM, we have count variable, like let's say field set to 1. And on the left, thread 1 is reading and incrementing it by 1, which is 2. And the result is not flashed back to the main memory. And at the same time, the other thread is reading that value of count and 1. So this is the problem, right? It makes our application to run incorrectly. So solution for this would be to use volatile keyword. So this is a special keyword we have in Java, which basically states that every time we read or write, so we directly talk to the main memory instead of that caches. So it makes sure that to write to the main memory and read from that main memory. So the other problem, like it's a famous one, like race condition. So here, actually, it happens when, for example, that multiple thread wants to change the value of count, right? And at the same time, they read this count into their own CPU, like CPU cache, right? And when they change, so at the end, the result should be 3 because we have 2 increment, but we get 2 because of that inconsistency. And here, there can be different approaches to solve this problem. One of them is to use synchronized block, where we allow, like, let's say we allow only one thread to make updates for the variable at a time. So we call that place also critical section as well. So one thread works with critical section at a time. Yeah, and I hope it was clear. And now let's talk about happens before guarantee. Yeah, to like talk about this, let me give some examples so that it would be easier. Here you can see these instructions, and they are independent, let's say, and they can be run in parallel. So, and also compiler is free to reorder them. So reordering does not change like the result. But here in the second example, it's not the case, because basically what we are doing is we need like first result while doing the second operation. So reordering this, this would cause problem. And also some more examples here on the left. We have, for example, instructions, and compiler is free to reorder them in a way that it does not the semantics of the program, so that our program still work like as expected, but with this reordering, we might like compiler provides some performance, right? So, and we can do these operations faster. And so this also can happen with our Java code. Here, small example where we have bank transaction exchanger class, and it has 2 fields, transaction, and the second one is the flag, has new transaction set to false. Respectively, we have 2 methods. First, store transaction, which actually, as you see, we are setting this transaction to the argument that's given, and changing the flag to true. So this is a non-volatile, right? And in the second part, we have take transaction. Basically, we wait until we have that new transaction. Once we have it, we return it. So this is the like store transaction method. As you can see, these are like independent. And what if compiler decides to reorder them? So something like this. So when, for example, multiple threads are working with store and take transaction, it causes problem, because here we are changing the flag to true before we are setting this new transaction, and at the same time the other thread here can return all transaction, right? So how can like Java memory model solves this? So it provides guarantee. One of them is happens before guarantee. So like happens before guarantee for volatile, right? it means that when we use volatile keyword for this has new transaction, everything is before that volatile write is guaranteed to happen before it. So compiler will not reorder it. So that our application will work as expected. And similarly, we also have volatile read happens before guarantee. This is basically while reading value here flag, for example, everything after this will happen after it. It's guaranteed that this volatile read will happen before other operations that comes after it. So here also, if, for example, compiler reorders this, it also causes problem. And similarly, there are other happens before guarantees, for synchronized blocks, threads, and now this was a quick introduction for this guarantee, and this was all I have. And thanks for listening. Let me know if you have any question.
Questions?
Okay, like this. So I have a question regarding that memory models, heap and stack. I just was really curious about that. If I have a sample like a class, person, or any name, and I'm going to create a sample 10 or 20 instances of it. So as far as we know, they will be created in a heap, like a 10 distinct objects. But we have such a term like static members. And as far as I know, they are not kind of specific for the object. They are the class specific some stuff, let's say metadata, or I don't know. And how they will be kind of stored in the heap, whether they will be stored in the heap or stack, firstly. And secondly, they are not object specific, they are class specific, and how they will be stored in the heap. I'm just curious about it and how it happens in the heap.
Thank you for your question. Well, everything related to static will be stored in metaspace. This is like as we have seen, we had different parts of memory, right? And this is like a place where all the metadata related to classes and the static variables will be stored there. Like before Java 8, it's called permgen, like permanent generation. And for some problems, it had resizing, and it was re-implemented as a metaspace. So these variables will be in metaspace, and these classes will refer to them.
Is it outside of the heap or within a heap?
I believe it's separate, and yeah.
They will kind of have the reference to that metadata, right?
Yeah,
While
for example, GVM needs to know, when working with classes, needs to know all the metadata about classes. So right, so this metadata will be stored in metaspace, and this they have talk with metaspace to actually get that metadata, right?
Oh, okay. Great. I thought that's yeah. I didn't know how they will be happen in there. Yeah. Thank you for clarification.
Can you give a brief overview about the stack and heap, the difference between them, and a brief overview?
Sure. In heap, we store objects. In Java, we have class, right? And with one class, for one class, we can have multiple instances of it, right? And all the instances will go to the heap, and we access those objects via references from stack. And is it understandable, right? And within this stack, every GVM thread is like a worker within our application, and every one of them will have their own stack, basically. And there we store primitives and references. Those references will be pointing to the objects in the heap.
So stack stores the reference of the objects of the heap, yeah?
Yeah.
Okay, thank you.
Thank you, first of all. And my question is that there are kind of three keys actually. First one is kind of JVM, and the second one is the heap memory actually, and the third one is the kind of hardware part of the computer actually. And we know that heap memory is kind of the way, the logical structure to manage the memory by the developers. But I have no idea behind that, what things line on the behind that, separating the heap and stack from the hardware part of the computer. And in that case, the question is that how JVM acts on that problems, actually scenario.
Well, thank you. As you said, like this is like abstraction. We can say that like at the end they will be like no, this heap and stack for the hardware, like there will be in main memory, like which is RAM, right? So like this is like a design choice. For example, first of all, for example, storing objects in stack would be like inefficient because stack like heap will be larger compared to stack. So, right, it does not make sense. Also, it makes that threads work heavily at some point, right? For example, when it has a lot of data and it's at the same time working with them. Instead, they have a reference to heap, right? And they work with references. And yep.
Oh, okay, thank you.
Thank you.
What kind of algorithms are used during a minor and major GC?
But that's a good question. Well, there are quite a few garbage collection algorithms that we are going to listen in the next topic as well. But the classic one is, I would say, mark and sweep, like where, for example, while this garbage collection occurs, this garbage collector marks that unused objects as dead, right? And the other ones as live, for example, and all the dead objects will be removed. Also, we have this compaction process as well, like to improve performance. After removing all the unreferenced objects, so garbage collector makes sure that the objects that is remaining will be compacted, so that we know where to start putting objects in the memory. So we do not loop through all the object graph to find those places, right? And we know that, we know beforehand where we start putting that objects.
Thank you.
And also, different garbage collection will have their own algorithms, and yeah, we will have deep discussion about this topic later.
Any more questions?
Thank you.
There's one for the last question.
So yeah. Well, let me introduce myself. My name is Javokhir. So as my name suggests, I'm a Java developer here at EPAM. And I'm a senior software engineer and working here for almost 3.5 years. And yeah, prior to this topic, we also had a GVM related topic, which actually Asliddin have already talked about it. And also prior to this, in our previous event, we were talking about the overall JVM architecture, so what actually it does. And today, as you asked, we responded. We're gonna talk about garbage collectors and how it actually works under the hood, and what types of the garbage collector can be used in production in the day-to-day life. So yeah, mainly that's the main information. And yeah. So, and also I represent a Java community Uzbekistan. So actually, besides of the MJC, we have the separate organization community called the Java community. So yeah, please feel free to subscribe and like, share, and etc. And yeah, like if you have any ideas, suggestions, or you want to become a speaker on the next events of the Java community, you can become it by contacting either me or Camila or any other representatives whom you may find on our website. So yeah, let's get started. So as you might see, we actually will talk about the garbage itself, garbage collector itself, with an analogy of the kitchen, because prior to this, we actually talked about the kitchen as an analogy for the JVM architecture itself. So here is our agenda. So first of all, we can talk about how the JVM architecture looks like, and then we're gonna talk about why we need actually garbage collectors itself, and we're gonna talk about its type and also the workflow that we have in our garbage collector, and also we're going to talk about what's under the hood of the strategy that was used in our garbage collectors. And of course, we're going to talk about some trade-offs and also some takeaways regarding to it. So here, our traditional representation of the JVM model, so with an example of the kitchen analogy, as you may see. So traditional Java application contains a JVM, because without the JVM, our application won't be running. Because in order to run the Java code, we of course will need a JVM. And also, if you know, the Java architecture itself contains a JDK, Java Development Kit. And inside of it, we have a Java runtime environment. And inside of our Java runtime environment, we have a JVM. But mostly, in order to application to be run, we just need to install the JVM itself, and that's it. So we can actually install it, for example, as a Docker image in our service, in our server. So in order to execute any code. So how the flow goes, as Asliddin already mentioned, that we have the class file is generated out of our source code, and that source code will be translated into the bytecode. So bytecode basically means instructions for the machine to execute. So like line by line, our compiled class file will be loaded into the JVM. So we can see that we have a class loader, subsystem, runtime data area, and execution engine, and of course, some native stack. And also besides of it, we have a garbage collection, which actually manages the memory altogether. So by looking at our analogy, we can actually imagine that our JVM can be considered as a big one kitchen, where we actually prepare the foods. So like by food, we can actually say, for example, this is an end result, end response. For example, in fact, our application can be just one example of the kitchen restaurant, right? Because the person who comes, the customer who comes inside of a restaurant orders some food. That's actually can be, for example, the request that being made into our Java application, which should be served. Under the hood, we have a team of chefs who actually prepare the food. Do some business logic so that we can actually prepare our result, send our result to end customers. So, for example, in this architecture, we can see that heap can be the place which is shared by among other objects, because it's called a shared area. It can be used, for example, as a fridge alternative, or like a cooking place, which is used by the other chefs as well. And the chefs themselves, they can be considered as the execution engines, yeah. So, and also class loader can be, for example, the storage where we actually store our ingredients to prepare the meal. So our meals can be represented as objects or like responses, yeah, some wrapped objects, let's say. And the cleaner itself, we can actually say that the garbage collector. So why we actually need it, of course, without cleaning up the garbage, there will be no room. Room to prepare the further foods, yeah, to be made. So that's why that's really important to have the garbage collector in our application as a cleaner, right? Because there will be no any room further on to prepare some food later on. Because, yeah, as I said before, so, oops, it's not working. Is it? Let me try once again. Okay, it's working now. So, yeah, as you might see, this is our heap itself. Yeah, the heap is shared memory space, which is used among other objects. Yeah, this is the place where the objects were being created in our heap. So that's actually how we represent the heap, just conceptually. Yeah, how we actually imagine it to be like that, but this is actually the outdated representation of the heap. Yeah. So, can somebody actually tell me what was changed or what was like outdated on this picture? Yes, exactly. Nice catch. Yeah, because this is actually prior to the Java 8. We have the permgen, yeah, permgen area of the JVM, and basically our heap we actually represent it as it like that, you know, like we have the young space, young generation, and the old generation. Yeah, old generation we also called as tenured, and the young generation we actually divided further into the Eden space, survivor space. We have a 2 survivor space, and also we have some virtual space in between. And then on the old generation part, we also have, besides it, a permgen. Yeah, like for example, when we create a new strings, or like when we interning the new strings will be actually created on the permgen side. And what was the problem? Because am I disappearing from here? Okay, so because prior to the Java 8, we actually encountering the out-of-memory errors. What's actually bad? This is bad because we will be no longer have enough space for our new objects to be created in our heap. So that's why later on, in the later versions of the Java, permgen was replaced with a meta space. Yeah, so the meta space is called a native memory area, which is not a part of the heap. Yeah, this is actually I would say this representation of the heap itself. So, for example, okay, yeah, this is a representation of the heap itself. We can say, for example, more like I would say more like stigmatized, or like this is not the real representation of the heap, I would say. In fact, in the Java itself, we have just mainly memory contains a heap and then non-heap area. That's it. Because the heap itself depends on the garbage collector that we use underlying of our application. This is actually the representation of the heap when we use the G1GC garbage collector. Yeah, because G1GC actually splits our heap into the generations called young generation and old generation. We actually talk about it briefly in the next slides. So this is, we can see that evolution of the garbage collections. So our G1GC, which is becoming a default since the Java 8 version. So like after the 8 version, we can see that this is all blue, and this is actually the default one. But prior to this, we had the parallel GC and CMS and the serial GC, which is not actually no longer be used. And some of them you can see that remote altogether in which version of the Java. And also we have the new garbage collectors, which actually have a generational nature, yeah, because, and also different garbage collectors like the Shenandoah and ZGC. And yeah, but mostly what's actually point, yeah, we actually don't care about what kind of garbage collector we use in our application, right? Because no one actually knows like what's actually G1 GC is, why it's actually default garbage collector, and etc. But sometimes you actually need to, this is actually, as I previously told you before, this is actually the heap representation after the Java 8, yeah? So because, as you might see from the previous slide, mainly our default garbage collection was a G1 GC, so that's why we were actually considering the heap like by splitting it into the definitions as called the generations, right? So, but this is no longer true, because when we actually switch to the different representation of the garbage collection, our heap representation will be totally different. So, but this is how it looks like when we use the G1 GC garbage collector as a default one in our JVM application. So basically it contains the Eden as previously defined survivor space, tenured, and which is also old generation, and then the meta space, right? So by default, 1/3 of the heap space is used for the young generation. So this is also, we have when we use the G1 GC garbage collector, we have like empirical observation as, which is actually, yes, sounds a bit dark, like young objects like must die young, like young must die young. So that's kind of, yeah, strange, I would say, definition of it, because, yeah, mostly young objects will be residing inside of our Eden area, and then how our garbage collector knows when is the time to clean up our GVM. So in fact, the garbage collector itself, the generations itself, will be split across the regions, so regions based, because it actually depends on how big our heap size is. And then garbage collector uses the algorithm called mark and sweep. If you actually were paying attention to the Asliddin's speech, he also mentioned about a algorithm called mark, sweep, and compact. So we actually mark the used objects, yeah, through the root. You might ask, how can we actually know which objects can be considered as the root objects in our Java application, right? Well, we have a thread stacks in our thread, right? Because when we run the application, the threads are being created because thread actually serve the request. So in our like kitchen analogy, we can actually imagine that threads are like waiters, yeah, in our restaurant, because they actually serve the clients, yeah. They actually like take the orders and come back to the kitchen, tells the chefs what to cook, and then after some time they actually bring it, yeah. So depending on our application architecture, it can be either like synchronous or asynchronous, yeah, for example. But this is actually a bit out of topic, yeah, talking about the threads. But yeah, this is actually to have more representation of it. So when we have the objects which is actually currently running in our thread, yeah, which is in active thread, so we can actually consider them as a live objects, yeah. And any object which has a reference from that root object, we can consider them as a live objects, yeah. And we actually mark those live objects, so like that, for example, yeah. We know the root object which is actually being used because we know how we know it, yeah. How we know if our current thread stack is active, we know by actually, we have also in our previous slide, if you looked at before, like we have the PC registers, yeah. In the PC registers, we actually tell currently which JVM thread is being run on our JVM, yeah. So that's how we actually know which is the current running application. Also, besides of it, we consider as a root, GC roots. It's also known as GC roots, we also consider the objects which are like statically initialized, yeah, during the class loading process. We also consider them as a GC roots because they actually will be created eagerly when we started our application. Yeah. So yeah, this is like for example, in our kitchen analogy, we can say that like eagerly initialization is like preparing the meal before it's being ordered. For example, like heating some stuff, yeah, like preparing some some ingredients so that we can actually make them like for example, cooking the meat, yeah, so that we can reuse the meat, same meat, in order to save some time, and then we can actually like make some, for example, kazan kebab, yeah, or like a pulao and etc. So that's actually we used. That's why I used the kitchen as an analogy, because as you know, like peoples of Uzbekistan, we love eating, we love cooking, so that's why, yeah. And okay, so this is how basically the GC works. So this is an algorithm called the marking. We mark the live objects, yeah, and then sweeping. During our JVM starts the cycle called sweeping the live objects. So in our previous architecture, you might see that we actually mark the objects as live in Eden, and then marked objects will be promoted to the survivor space, yeah, and then all space will be cleaned all together. So that's how we actually do it, and then they end up being on the tenured space. But actually, that's a bad. Like as I mentioned before, we try to make them die on the young stage, yeah, because tenured space will be leading to the higher GC cycles, because by looking at it, we can also have the two cycles of the garbage collection, which is called the minor GC and the major GC. The minor GC takes place on the survivor, on the young generation part, yeah. And the major GC, this is like a full GC time when we have a garbage collection cycle inside of our old generation part. So this is how we represent the G1 GC, yeah. This is which is the default garbage collection, which is used since the Java 8 until the Java 24, right? We have, like, if I'm not mistaken, the latest one, Java 24 of Java. So this is like promotion of the objects, yeah. We actually, like, we also known as the aging. So we actually mark them, like, for example, from the Eden, we actually move them to the survivor space, and after we move them to the second survivor space, and they end up on the tenured space, yeah. So we already talked about it before. And then unreferenced objects, which are also considered as dead objects, will be cleaned up during our garbage collection cycle. And yeah, this is how the G1 GC represented, as I mentioned before, because in the Java, we actually, this is not how it looks like. On the Java itself, we actually divided it like on the memory. This is not how it looks like. We just actually generated that diagram so that it will be easier for us to represent how the JVM itself, how the heap itself like looks like, yeah. But in fact, in reality, it looks like this, how the memory is being placed, how the objects are being placed, yeah. So like, because all of them are like checkmate plate, yeah, we have like colored places, but yeah, in fact, they look like that. And yeah, we actually group them inside of a generations. But also we have a different garbage collections like ZGC, yeah, and then Shenandoah. So ZGC was introduced in Java 15, and also Shenandoah was introduced in the Java 15, but all of them cannot actually replace the G1 GC, because G1 GC is a traditional app which is more balanced. Yeah, if you have a question, yeah, okay. Previous slide. Mm-hmm. Well, we actually, G1 GC, this is how it represents the young and old generation. Because like in our application, this is the, I would say, the concept. Yeah, both of them are used, but we try to use a short-lived objects, because in our like cloud native applications, it's better to have a short-lived objects, because we don't want to have a object which actually remains alive for a long time. So that's not actually good for our health of our application, because actually it takes a memory. If it takes a memory, it takes a computing power. If it takes taking a computing power, it takes more money, yeah, in our cloud application. So that's why this is really important. But this is just a concept, yeah. We divide it into the young and old, because why we consider them as a young? Because when they create it, they should die, you know, like, because for example, we have a incoming request, yeah, from the client, for example, like ordering a pizza, like having a business logic in our application. So some couple of classes were created, yeah, some couple of objects were created. During that logic, some execution happens. So that's it. We don't need any state anymore for these kind of objects, yeah. So it should die. So we actually, not we, but people from the Oracle, yeah, decided that it's better to have the minor GC, yeah, to have a cycle. It's like in our kitchen analogy, let's imagine that, you know, the person who is like a cleaner cleans the places, yeah, like washes the dishwasher and like prepares some, cleans up the utensils in parallel to chefs who actually preparing the meal, yeah, because no one is actually interrupting each other's job, yeah. So that's why it's called a minor GC, yeah, because it's actually prepared. Like we actually chop the onions, for example, during the preparation of the plov, and then at the same time we're actually cleaning up the place, yeah. So that's how it's called a minor GC, yeah. But in the major GC, we have a wedding, yeah. After the wedding, we need to clean up all together, yeah, because we had a heavy operations, and that's why the major GC has a long pauses, yeah, because yeah. Mm-hmm. So it's situated in the major GC, not minor GC, right? Yeah, this is how it looks like, how it represents in the young generation part. Yeah, we actually promote it from the young generation to the Eden survival space, and later on to the tenured one, which is the old generation. So, as I mentioned before, old also called as a tenured part of the heap. So yeah, we also come back to the Q&A session as well. So. And also, as I mentioned before, ZGC, this actually works totally different from the G1GC, yeah? So when we use the ZGC, the standard representation of the heap is no longer actual, because we don't have a young and old generations, yeah? So we have a generationless, yeah? So like all the generations are equal. So it's like a, I would say, like from the structure, it's like more like socialistic, yeah? Like, or like a communistic approach, yeah. We don't have any kind of classes, we don't have any kind of aging promotion, yeah. We just like split our heap into the regions, yeah. Like the size of the region can vary depending on the heap size, but basically it's a block, yeah, from the 2 to 16 megabytes. And it's like the same as like cleaner, you know, like cleans one area while the chef cooks the meal. So we don't have a like major, minor GC as in our G1GC application, yeah. But in ZGC, we use a colored pointers and the load barriers. That's actually underlining architecture of our ZGC architecture. So how we can use it? We can actually use a ZGC, like a plus, use a ZGC when we actually starting our Java application by passing a Java argument in our when we're running our Java application. That's how we enable the ZGC. This is actually ZGC was why we use it, because it has a shorter latency, yeah, like a lower latency in comparison with the G1GC, but it has a less throughput in comparison with the G1GC, because G1GC is like a perfect one, yeah. It can do everything. It's like it doesn't have, like, I would say, it's just like a traditional one, yeah. It's not the perfect, like does not do the perfect job, like doing for the one that, but this is a stable, yeah. This is because that's why we actually use the G1GC. That's why mostly our web application rely on the G1GC. So you may ask why we actually need other types of the garbage collection in that case. Well, that's actually valid questions. We actually use it, for example, when we need a low latency, like for example, trading application, we need just in a millisecond response, yeah, because like in trade stocks, the prices of the stocks like changes in a matter of the seconds, like when some situation or like some kind of change will happen in a politics or like in social life. So the stock price will like fluctuate, and in order to have the real time, like a low latency application, we actually use the ZGC for the trading application and etc. And the Shenandoah is like a more, I would say, more or less like ZGC. It still uses the pointers, but it is like a kind of pointers which is actually represents like C-like pointers there, like a forward like pointers, like pointing from one side to another. We don't have a more like a compact region based as our ZGC. So in our next slide, so this is like when we can use, in which purpose we can use what kind of ZGC. And also, if you pay attention on the slide, like we also, prior to the Java 21, ZGC was like generationless. Yeah, we don't have a young, old, and etc. generation. But in the Java 21, people from the Oracle decided that let's make the ZGC as a generational one. Yeah, because that's actually how we learned to write our application. Yeah, relying on the G1GC. This is because it is more like a suitable one, like to have the representation of the G1, the representation of the young and old and minor and major GC cycles. So, and also besides, I forgot to mention that Shenandoah was developed by the Red Hat company, but it was later adopted by the Oracle JDK. But mostly G1GC, ZGC is a product of the Oracle, which is the main contributor to the Java, which is actually stands behind of the Java technology. So all of them actually basically the experimental or like because always we have the default one, G1GC. So you can see that when we can use it, like low passes, but good throughput. So that's why the generational ZGC was introduced later on in our Java 21 plus. So yeah, and also parallel, so it's no longer needed like CMMS. It also no longer actual. That's why it is rarely used in our application. And also, let's talk about shortly about the JVM monitoring tools. Yeah, because we actually need to observe of our application, how it actually behaves, how it actually runs our application, how our application is being run in our JVM. So we have a command line utilities in our JDK. So if you install the JREA, not a JREA, but JDK, it contains some utilities tools, command line tools developed by the Oracle, so that you can use it for the monitoring purposes, some observation purposes. Yeah. So Oracle provides us GStat, GMap, and GConsole, so you can actually use whatever you want. So basically, all of them does almost the same job, like showing us the metrics, the analytical data of our application. This is not a logs, as you see. This is actually like measuring like how clean our JVM kitchen is. Yeah. So by showing, like you can see that JStat /GC, it also has a different parameters, arguments to represent, but here we actually interested more about how the garbage collection works. So we actually the second argument after the first argument after the GC, we have the PID, which is actually the ID of our running Java application, and the next one is the interval. And then the 7 is like how many times we want to represent. Like each second we want to see the data of our metrics of our Java application. So you can see that the SOC, like SO1, is like the reclaimed the spaces used in our Eden spaces, survivor spaces, and then like when we have the prefix U, it means like how much memory actually used. So you can see that, for example, this one, like C0, is like have a 0, like no space is used, no space have been given to the survivor space, and then like for example, this is like for the used ones, this is for the used ones, this is for the used ones, this is actually claimed ones, so the claimed survivor space and etc. For the Eden, this is how much space were given as in megabytes, and this is how much is used, so this is actually the application, and also on that side, like yet YHGC, you can see that number 33. It means that how many times young generation was cleaned up. Like this actually shows that the number is 33, which is actually really good. And while you can see that FGC means the full garbage collection cycle, which is 0, which is really good because we actually aim for the 0 garbage collection, full garbage collection cycle, because it actually means that we have our objects are like dying young, while it's not stopping our application from from functioning like normally, And this is also, I actually got this data from one of our production application, But can somebody actually, by looking at it, can see some like problem here? Maybe if you guys, some of you have tried before using such analytical tools, can somebody tell what's the problematic here?
The interesting thing is all of them are the same, like the
numbers, this is actually, I would say that the numbers are given in kilobytes. So it's like most of them, like for example, OC means a old generation, like a 180 megabytes were given, and then like that many is used. Okay, I'm going to tell you here, so you can see. I'm going to give you a hint here. So we have an MC here, right? This is the space given to the meta space. Currently it is like a 130 megabytes, but we have a meta space used 128 megabytes. So that's actually the problem here, because we almost loading up our meta space, because we actually have a lot of threads. We have like a lot of data being created eagerly during our application. So that's why we have that kind of level. Like if it actually reaches it, either it will actually throw an out-of-memory error, like related to the meta space, or like it will trigger the full GC cycle, which is actually slows down our application. But this is actually the project of one of our startup products. So that's why no one is considering about optimization at the moment. So because it's not like it doesn't have that many load that is projected. So that's why, if of course because in a startup it's like it's not that many, not so important, I would say, to pay attention on that kind of details, because this is more like for the enterprise applications, because so that's the point. And also GMap, use it for the generation the Java heap dump, so that we can observe what kind of memory leaks do we have, and the histogram of it, like GMap, shows like how many classes were created and how much spaces do they take. So you actually can run your own application and actually see such numbers on your own. So that's actually mainly it from our slide. Do you have any questions, please? Let's go ahead.
My question is that in the practical manner, in solving with the real world problems in our application, let's say we might work on the large amount of data. Let's say a million amount of data per request in our application. For that case, as an engineer, we need to consider how JVM and the garbage collector impact on the memory usage on
exactly.
our application.
Yes.
And in such case, we need some customizable way to manage and to make the memory usage more optimized. So in that case, can we do some manual and customizable approach or manual coding to make more optimized the memory usage with garbage collectors or some kind of approach strategy actually. So that's the question.
Yeah, that's a really nice question. And in fact, the point is we don't have to, because Oracle already provided us the different strategies for our garbage collection, right? So we can use a like G1GC. If you need like standard for the web application, just APIs, use G1GC, yeah? If you need a like trading applications, yeah? If for example, we have the threshold, for example, from the 4 gigabytes all the way up to the 16 gigabytes of the heap space, we can actually consider using the G1GC. That would be more than enough, yeah, because we will for our traditional application. But if we have, like, for example, bigger than the 16 gigabyte of the heap space all the way up to the 64, we can consider using the ZGC, yeah. And from the 64 to the 128 and more, we can consider the generational ZGC. In fact, such heap space is really big, but in fact, like, if we use, for example, 64 gigabytes of our heap storage, it will be kind of one big monolithic application, yeah. But it also depends on the requirements. But mainly, we should not aim we should aim for decreasing or like removing the memory leaks altogether. That's the point, you know, like because we should not consider about like changing what's already been done for us. In fact, we can, if we write more cleaner code. By cleaner code, what I mean, like, for example, we have a producers, yeah, they should be closed afterwards. For example, in our application, when we use, for example, Kafka, yeah, we create the Kafka producer, open up the connection, but sometimes we forgot to close it, yeah. So that's why it's also considered as a memory leak, because every time we call that logic, the new objects will be created, and then bang, we might get out of memory errors. And also in our callback logics, because it has a hidden reference, yeah. For example, in our application, when we use the objects and we call a callbacks, by the callbacks, we usually use anonymous objects, yeah. Anonymous objects, they actually, they have a reference, but they're no longer active. So garbage collector falsely consider it as a live object, and then falsely recognize it as a dead object. So that's how it will be accumulated, yeah. And also having too much usage of the static initialization, yeah. We can actually throttle our application even during the class loading process. So we actually consider this kind of situations, closing up the memory leaks by avoiding considering about the proper usage of the callbacks, and also closing the open resources. And yeah, also we have a different, and also usage of the references. Yeah, we have a weak reference, strong reference. Yeah, because a strong reference holds the object and keeps them alive. Yeah, weak references use it in the caches. Yeah, cleans up the memory faster. But if we actually misuse it, so we end up having because having those tools will not guarantee that we will no longer have the problem with the memory. But proper usage of the understanding the logic behind of the objects that we create is really important. So that's why we should focus on our code, how we write. So not focus on the tools that's already been developed by the Oracle.
Also, I'm going to add up to the answer. Javokhir said that you have to avoid everything from the application, but there is sometimes situation where you do everything perfectly, and traditional garbage collection configuration is just not good enough for you. For example, like you said, million records. Usually what you do in applications, you load million records. For example, do it in batches, 1,000 of them, and then calculate some aggregation, right? Like a sum. But sometimes it's just a request, like just retrieve me all million records, right? In that case, what happens is you put all million records into young generation. That's a big problem. Most of them go right into old generation too. They just don't fit. And in that case, what you can do, everything Javokhir talked about, the structure here, for example, the size of the survivor spaces, the size of the young generation, number of times the object has to make through the survivor space, because in default configuration, your object is born in Eden, goes into survivor space 1, 2, 1, 2, and then after 8 cycles, it goes into old generation. Even that number is configurable too. Everything is configurable. What you can do sometimes is, one of the parameters that Javokhir called was max pause time. You can pass those parameters, and then the garbage collector is going to adapt to them. So for example, in case where you actually have to load 1 million, first thing, you want your young generation big so that everything fits. You don't care that much about the old generation because it's not a long living object. It's just, it takes a lot of time to load that much data, return it, and then you can just garbage collect. But if it makes to old generation, then major garbage collection cycles has to happen, and that takes a lot more time. It's way harder. So you have a lot of capabilities to fine tune it. That's why we need to understand the use case. Like Javokhir said, for most scenarios, default configuration is good enough. Your scenario is a specific one, very rare, because usually you just generate a report on million objects, right? That way you just batches, aggregate into one small thing, and they die in the young generation. But yeah. Okay.
Yeah, we have different strategies. Yeah. Using batches and like having a asynchronous processing, like having a not like synchronous but asynchronous. You're using the broker and then like doing them in batches. Yeah, as Elior mentioned. Yeah, please. Yeah, you're welcome.
As you mentioned about the strong reference, if object is eligible for garbage collector, but it's still reference to the strong reference, what will be in this case? Does it collect
strong reference?
Yeah.
Strong reference.
Strong reference. So that's collected on what will be the case in this situation. And then next question, there is a different algorithm for garbage collector. The finalization method and collection can be different, So which one is more efficient, or the purpose of the usage in terms of using, can we use all of them in one particular problem, or there is some certain way that they used in different situation?
Yeah, interesting question. Well, regarding the references, in fact, usually how in a perfect scenario, we have like local variables, and inside of a local variables we have a local scope, When we actually enter that scope, the object should be created, but when we exit it, so it should be no longer active, All of them should be garbage collected. But when we have like memory leaks in our application, of course, it might still be inside of our application, even though the logic is no longer active for that kind of place. And also, for example, we can use thread local, the classes, like we have a thread local class, which also like keeps, which is also creates the objects for the thread for our threads, but also misusing it also can lead to the memory leaks, because thread should be like created and then it should be fade away during our cycle. But if they actually collect it and not reclaim it back to the meta space, because our threads are being created on the meta space, because architecture it is like the thread per request. It actually sticks to our OS, underlying OS. So that's how actually created the threads on our application. But misusing them can lead to the meta space out of memory error. But when we have the meta space of it, misusage of Like, for example, when we have a deadlocks, yeah, in our application, for example, misusage of the asynchronous reactive framework with a blocking, for example, database. Yeah, in that case, when we inserting, for example, with the batches, because we also need to be really pay attention to the case when we use the batches, because in my production experience, I also have such kind of scenario, like we have a reactive application written in the Vertex, and our job was like to get the data from the Kafka and then push the data to the Postgres. But because of some misconfiguration in our batch cycle, we're having a process of like deadlock, like one thread was like blocking one row of our database and holding the next one, but it was already been locked by the previous thread, which is also asynchronous, and that kind of nature was leading to the deadlock, and as a result, we were having a out-of-memory errors in our metaspace. And the solution was like, we might have it, but we have the retries for it, yeah, like exponential backoff retries. By doing that, we were able to leverage that kind of problem. But that's also another point of it. And can you remind me your next question?
Next question. There are different types of algorithms for garbage collector. Finalization and collection can be vary. So which the purpose of using this, the efficient one?
Well, to be honest, yeah, the only thing that I know that which is used as the underlying algorithm for the garbage collection is like mark, sweep, and compact. That's the main idea, like marking the live objects, sweeping the old objects, and then compacting, like defragmentation. Because if we represent the memory like that, yeah, we have objects created here, here, and we have a fragmented pieces of the memory. Yeah, so our job is to defragment them together so that they will be contiguous to each other, and then we have that unused space here. So that's actually the algorithm that I know, but of course, but it depends on the different usage of the garbage collectors, like having the generations. But basically, that's the one definition, like the standard that how should be used, like in a simple words.
Thank you very much.
Welcome. Thank you for the question.
I know there is a concept called stop the world, which occurs during garbage collector. And if I'm not mistaken, all the processes are stopped for a while. So that's the question, which threads are stopped during stop the world?
Yeah, that's actually a nice question. But in fact, the stop the world is like, as the name suggests, stops all the process, except the garbage collection. It's like we have the kitchen, it is small enough that when the cleaner works, it stops all the process of the cooking, So because there is no space or like no process, no memory for the other threads to work on. So that's how it calls. But we don't have no longer the process of the stop the world, because this is more like for our serial GC, when we have a one thread, like for the garbage collection for all the operations, because like one thread was like one cooker was cooking the meal, and also after some time he or she stops cooking the meal and then cleans all together, have a tidy space. So that's the process of the stop the world. But right now we actually consider about the major GCs. So like major GCs also affects takes some latency. It actually slows down our application, but not as the stop the world, because the stop the world was like more for the serial GCs when we have only one thread in our application.
I'm gonna also answer a bit more on this. Yes, like he said, in parallel, stop the world was a big issue, because you stop all application threads. Imagine somebody requested something from your server, and then garbage collection started. You as a requester would just wait for the garbage collection to happen. So parallel, for example, GC would clean it up in parallel, but everything would stop at that moment. The whole point of concurrent mark sweep is that you try to reduce that stop the world. You can't completely remove it, because there are some points that you just have to stop everything. For example, when you're deleting the objects, there are some stages that it happens. But the thing that takes the most time is going through each object, like finding trash, marking the trash. Those things are done concurrently. Even after you marked everything, which takes a long time and happens concurrently. So you didn't stop any application. You stop it for a very short time, and that doesn't affect your application that much. For example, imagine before garbage collection started and your request response rate spiked to 100 milliseconds, right? But now it only spikes to 5 milliseconds. So those things happen. The collection of root objects, for example, that also causes the stopped world. So the whole point of this is to do as much as you can concurrently, and the things that stop the world, reduce their time to minimum.
Yeah, also in addition to the previous answers, we also still use the serial GC, but in a really low level environments. Like for example, when we have IoT, yeah, when our heap size is like less than 1 gigabyte, so we can actually consider using them. When you have a like not that memory intensive operations, it can be used sometimes, yeah. So it's, yeah, that was a mistake, yeah, to say it's no longer used. Yeah, you're welcome. Any more questions, guys? Yeah, please.
I'm not a programmer, but maybe it's not a particular topic, but I saw a question somewhere about the critical difference between the, how it's work, I don't know. So about the critical difference between JavaScript and Python. And one of the answers was that the JavaScript requires a lot of memory compared to Python. So but in order it operates faster. But I'm just interested in your opinion on this.
Yeah, nice question. But in fact, yeah, mostly like dynamic typing languages takes a bit more memory in comparison with the static typing languages, because we have a loading process, we have a because in fact, like Python, as I know, was written on top of the Ceton, which is a library of the C language family. But mostly, yeah, I would say, yeah, from the perspective of the Java, I can say only like we can have a more, I would say, like we can actually leverage using the eager initialization with a lazy initializations in our class loader processes, and also we can also define a static initialization, and that's actually makes more sense to have a faster application. But in terms of the JavaScript and the Python, I cannot say, I cannot answer properly to satisfy your question. Yeah.
Thank you.
Welcome. Yeah, any more questions?
Also, sorry, everyone, no more questions for now. Let's get to the lunch now. Any questions to Javokhir you can ask personally. We're going to have around a 25-minute break, I believe. So, yeah, please, everyone, feel free to get some pizza. Please get up.
Yeah. Thank you, guys. If you don't have any questions.
Thank you, Javokhir.
Thank you. Thanks all.
Hello, everyone. My name is Leyla Bakhridinova, and I'm a software engineer at EPAM company. I've been working at the company for 2 years, and today's topic is Introduction to Cloud and AWS Overview. So the question is, what is cloud? Работает. Just give me a moment. Wait. Today's agenda is as the following. We're going to find out what is cloud and its computing and deployment models. We're going to talk about AWS and its well-architectured framework. Then we're going to delve into AWS training and certification programs. And in the end, we're going to cover Java software and cloud development kits. And if you have, we will have ample time to answer your questions if you have any. So our main question is, what is cloud? We don't have any definition right now. So there are 3 types of cloud deployment models, public, private, and hybrid. Public cloud is usually owned by a third party and managed by it, and you access the resources over the internet remotely. While in private cloud, it's a cloud and hardware managed by a single organization for their purposes, and it's located on premises. And hybrid is a combination of those last 2. It combines hybrid and public cloud, and resources are connected within networking platform. Now let's talk about cloud computing models. We have 3 types of them. Well, the first one is on-site, where you basically manage everything, and it's called on-premise. And other than those, we have infrastructure, platform, and software as a service, the computing models. In infrastructure as a service, you do not have any ability to manage the hardware, but you still have the ability to change operating system, middleware, and runtime. In platform as a service, you have, I am sorry. In platform as a service, you have even limited ability to manage your cloud. You only have the ability to manage the applications and the data that flows through them. And in the end, we have software as a service where everything is managed by a third party, and this third party already has some end users, but you still have the ability to integrate that software in your existing systems. So now that we know cloud deployment and computing models, we can basically describe what cloud is. Cloud refers to a model of computing where resources as a storage, database, servers are accessed through the internet. Cloud environments can be deployed in different ways, as we talked, private, public, and hybrid. And additionally, we have different cloud computing models as infrastructure, platform, and software as a service. Here in this slide, you can see different lists of cloud providers like AWS, Google Cloud Platform, Azure, Salesforce, Oracle, Dropbox, and Alibaba. And today we're going to talk about AWS because it's a single cloud that I'm aware of. So AWS is a huge cloud provider which provides different services within different stacks. Here in this slide, you can see that it provides compute in form of EC2, Lambdas, and AWS outputs. It also provides storage and database solutions in form of simple storage service, or it has a unique database NoSQL database in form of DynamoDB. You can also do some networking and content delivery using AWS, and AWS also provides you with analytics tools. You can also enable application integration, for example, for event-driven architecture using simple notification and simple queue services. You can definitely manage your finances there. And lastly, you can manage and govern your own cloud using AWS. So as we said, AWS is widespread globally, and in this video we can see that AWS is available in all 7 continents. So let's see what we have here. It is available in North America, South America, Europe, Middle East, Africa, Asia Pacific, and Australia with New Zealand. You can follow this link and pretty much access this website and learn about AWS regions and AWS availability zones within regions on your own. So, next. Our next topic is AWS well-architectured framework, which contains 6 pillars listed here. AWS well-architectured framework describes key concepts for you to follow best practices while implementing your cloud. You can also follow this link to learn more about it in AWS documentation. And we're gonna delve into each pillar one by one in the next slides. So the first one is operational excellence. This pillar focuses on running and configuring your systems for continually improving them over time. AWS has developed a resilience lifecycle practice which covers 5 initiatives: setting objectives, designing implementation, evaluating and testing, operating and responding by learning. So you can pretty much, at these stages, use any strategy, service, or mechanism to cope with some errors and, most importantly, learn from your mistakes. Next pillar is security. When we are in cloud, our main concern, one of our main concerns should be security, where this pillar focuses on ensuring confidentiality of, for example, personally identifiable information, and giving the users and developers using the cloud least possible privilege. When I hear the word security, the first thing that comes to my mind is principle of least privilege, which is well described in this documentation here, and it's also known as principle of minimal privilege or principle of least authority, which means that no matter how experienced the engineer is, they should have least possible privilege to perform their daily tasks so that they are not given more than they need. For example, even the architect has 20 years of experience, they shouldn't have, for example, delete operation ability on database. So you can never trust your architect with years of experience with such a huge destructing operation. Next pillar is reliability. Reliability focuses on fault tolerance, where you basically need to make sure that if you have something faulty in your services, you should have the ability to recover from that failure without manual steps. When I hear the word reliability, service reliability engineers come to my mind. This concept was initially defined by Google, but it can be applied to anything, not only cloud, but any service you are implementing. So basically, you need to make sure that your services are reliable and they are serving your end users without big interruptions. Next one is performance efficiency pillar. You need to make sure that your system can withstand different performance dynamics with your number of users growing, and maybe they don't use your system at night as much. So you need to also make sure that performance is okay when they are not sleeping and using your system actively. So this pillar is pretty much about it. And AWS provides you with performance and capacity management, which you can learn about using this link. Next one is cost optimization. No matter you are using any cloud or system, you need to always monitor your costs and do not pay more than you are intended to, or do not pay for those resources that you are not using. This pillar focuses pretty much about it. And AWS provides saving plans and reserved instances for EC2s so that you can design fault-tolerant and cost-optimized systems with up to 72% discount. And it also has spot instances which can gain up to 90% discounts for you. And also it has dedicated services like billing and cost management, where you can monitor your costs for what you are paying and whether you need to update something somewhere. Our last pillar is sustainability. AWS is trying to commit to reach to net zero carbon emissions by 2040, and they are making their best to achieve their sustainability goals. And as always, you can learn more about sustainability by following the link provided here. And our next topic is AWS Training and Skill Builder. Now I wanna yeah. So if you follow the link provided in the slide, wow, let me actually do that myself. This is a separate platform that contains hundreds of courses based on your preference if you are interested in learning cloud. Whether you want to learn the cloud by your cloud role, if you are a data engineer, developer, DevOps, or machine learning engineer, you can find the related courses there. Or if you want to learn by product domain, you can also click here and check out what AWS can do, for example, for games, blockchain, data analytics, Internet of Things, artificial intelligence, we cannot skip that today, satellites, and more. So yeah. Next up is AWS certification. AWS provides you certifications programs in case you are interested in checking your knowledge of AWS. It has 4 different levels: foundational, associate, professional, and specialty. In foundational certifications, you are not expected to have any cloud experience. You can test your basic knowledge of cloud. In associate certifications, you need to have prior experience with IT and cloud, and also you can validate your core AWS skills using associate certifications. The next up is professional certifications. You are expected to have more than 2 years of experience with AWS to pass these ones. And lastly, specialty certifications are designed for you to demonstrate your expertise in particular field, such as security, advanced networking, and machine learning. So now we can talk about other things that AWS provides. One of them is distribution of OpenJDK provided by AWS named Coretta. You can see that this link includes all the long-term support versions of Java here. And by following this link, you can pretty much download any JDK of your choice, and it has a detailed documentation which is accessible via this link. And you can check out the benefits of Coretta. Next up is software development kit. I want to define this thing first before moving on to opening links. So software development kit in general is something that can connect your services written in any language with the systems that you want to connect them with. For example, AWS SDK for Java connects your Java microservices or even simple services with AWS services, and they provide debuggers, compilers, and libraries that are ready to use so that you can seamlessly integrate them both. It has actually two versions. One of them is AWS SDK for Java like this, and the second one is with V2, which you can find in GitHub. Let's do that together. So if you follow the first link, you will be prompted to this GitHub repository, and if you are patient enough can scroll down to README file, you will notice that AWS SDK version 1 has announced end of support by December 31, 2025, and they strongly recommend you to migrate your services to AWS SDK version 2, which is here. As you can see, this repository is much more scrollable, and it has all the related documentation for you to start using AWS SDK 2. Last but not the least, apart from Java development and software development kits, AWS provides Cloud Development Kit, which was initially designed for TypeScript. And if you open this link, you will notice that this repository is written in TypeScript, but as CDK itself supports JavaScript, TypeScript, Python, Java, .NET, and Golang languages. And in case you think that some other language also needs to support CDK, you can open the CDK documentation in AWS and add yourself to voters of that language so that you can promote it and AWS can start designing it for you. That brings me to the end of my presentation. We can start answering your questions if you have any. Yep.
We have in database we have high availability, and also we have standby when we have a crash in the main part. Yes, in the database. In the cloud, how we can preserve this situation? Does it support the high availability in the cloud?
If you remember, I mentioned DynamoDB in AWS, NoSQL solution for databases. So basically, for databases, we have such a principle called CAP theorem, which stands for consistency, availability, and partition tolerance. And databases, NoSQL databases, can only follow one of those two out of three principles at a time. So if the database is highly available and consistent, then we cannot guarantee that it can be fault tolerant. The same goes to other two. Like if it's fault tolerant and available, we cannot say that it's consistent. So DynamoDB is non-consistent solution. So it is highly available and partition tolerant. But if you want to make sure that your database needs to be consistent, you need to pay more for such operations. So it supports consistent operations, but it's not out of the box. So your basic operations are non-consistent. So in that cases, you need to choose between databases based on which principles they follow and which one you can close your eyes on and which ones are must-have for you. I hope I answered your question.
So for traditional RDS, which is relational databases, you can, for example, create multiple instances with the replicas and put them in different availability zones. So each region has multiple availability zones, and you have an instance in each one of them. And even if one of their availability zones crashes, your database is still going to be up. And if you want to go more, you can do it multi-region. So it's deployed in multiple regions. And even if the whole region dies in AWS, you will still have your database running. But of course, more availability you want, more instances you will have to have running, and that increases costs a lot. So really depends on the business case if availability is so important to you. But even just multi-AC is usually extremely highly available. Of course. Well, there is a way you can connect, but it depends. If your whole infrastructure is in AWS, then it's just your consumers that have to access it, right? Customers. If your customer doesn't have internet, of course. But in the cloud itself, there's a lot of, let's say, availability for the connections too. Everything in the cloud is made highly available. But if you connect, for example, your application, which is on premises with a database in the cloud, if connection from your on-premises data store to the cloud breaks, of course, your application is going to break. But everything is going to stop working in that case. There's no way around it if your connection breaks. So you have to ensure that that connection doesn't break. Oh, the thing is, wherever you're running your database, you're not running it on your own local system, right? In local system, it's good. Still, nobody says local databases are not needed anymore. Local databases are for development. AWS is very good for shared environment when your other team members have to access the database, and production too. Imagine you have an application and million customers, they're not going to access your home laptop for the request, right? They're going to go to somewhere, and that somewhere, you can't access it without internet anyways. In any case, it's going to be somewhere else, but not your laptop. So yeah, of course, the connection is still needed. Any other questions?
Hello. Thanks for the presentation. Currently, I have a problem. Like, I would like to know your suggestion about it, and I would like to sell a Windows application for users, and I need to manage the database, creating an account, and enabling users to buy my products by entering their credit numbers. And I would like to know, is there any easy solution to just manage this through third-party applications?
Wow. Let us think. So you need a third-party application for you to perform banking operations?
Yeah. Specifically, like, I have example, for instance, I have a game application, and I need to just sell it. And in order to first just users to get it, they need to create an account on a website, and through this account, they also able to just enter into my game, and also manage the payments through web, and securely just takes the transaction on the website, so that all the like management of the data between the clients needs to be on just in the cloud system. Maybe it's a third party or custom made, like locally served system. Like, yeah, that's one.
Well, I got your question. So see, if you have something like really like that in mind, it won't take one engineer to develop all of that thing in one day, you know? So well, the way you are talking is you need integration with, for example, in local terms, with Uzcard, maybe with like Humo or stuff like that. Also, you need to make sure that like personally identifiable information is secure. Like we have lots of other government regulations for those, right? So for that, a team of architects can come up with some solution, like with component diagrams and, you know, with their expertise in this particular domain, like, how was it called? SMEs, subject matter experts. So those have worked with such a system before. But one thing that is coming to my mind, like it may be just, you know, random solution, but from what I've known all this time, you can use like manage your user authentication on authorization related stuff with Cognito in AWS. Also, AWS supports all those HIPAA and regulation stuff for you to make this process easier. And well, for integration thing, you can basically create such a layer of, you know, networking so that you are securely accessing the third-party banking system. We have those solutions ready there too, and then you are making sure that like those transactions are doing all right. So when you want to make your database like more about transactions but not about you know, availability, you need to opt out of NoSQL, because ACID usually follows SQL databases, right? So yeah, in this case, you need to select the proper database. You need to come up with a solution for proper authentication and integration with a third party, which cannot be done like in a minute, you know? So it's a hard question, I agree, but
That's cool. That's cool. That's cool. Yeah.
Thank you. Any more questions?
Okay. Thank you, everyone. Thank you, Leyla.
Hello, everyone. Thank you for being here today. I really appreciate that you find time to join this session. My name is Ruslan, and today I'm going to tell you about MCP server. What is MCP? And here I have to be honest with you. A few weeks ago, if you had asked me what MCP server is, I would have looked at you with completely blank face because I didn't know. So here's the fun part. I agreed to give this talk before I knew what MCP server was. And I thought that it will be interesting to learn what is it and share my journey with you. So, all right, what we're gonna cover today. First, I really want to introduce myself and tell you about my journey in AI. Then we will speak about what is MCP actually is in plain English, no buzzwords. After that, there will be a fun part. I will show you how I built MCP server in 15 minutes using vibe coding with Cloud desktop. Then I will also describe you that MCP server not just only tools, but also what does it support. And finally, we will wrap up with takeaways, and I will open it for questions. So let me start with my story. I'm lead systems engineer in EPAM, or simply DevOps engineer, and my daily life is Azure Kubernetes, Azure Cloud, Bash scripting, PowerShell scripting, and things like that. Something like why this pod crashing at 3 a.m. kind of stuff. So my relationship with AI, it's straightforward. I use ChatGPT when I need to find out something quickly. GitHub Copilot is my coding buddy, and actually LLMs become my secret weapon in writing emails and documentation, because who enjoys to write documentation? But things that I'm trying to keep my finger on the pulse of AI technologies, so I push myself to participate in different activities like hackathons, code battles, or presentations like this, to be current and not falling behind. About a year and a half, I joined such event. It was our internal hackathon where we took on pretty ambitious challenge, automated vulnerability exploitation using LLMs. There, it was first time when I get my hands dirty in AI tools, how it works, LLMs, how LLM interact with other systems. And let me tell you, what we built completely blew my mind. Here how it worked. We fed it a vulnerability as input to our solution, and then LLM scraped websites, tried to find existing exploits, code, then it tried to use these exploits to hack system. To make this happen, we built a lot of custom tools. A web scraping tool which allows LLM to execute different commands in Kali Linux console, create scripts, and run them. I was incredibly impressed because it was my first time when I saw that actually LLM can do things moment. Now fast forward. Sometime later, one of my colleagues from DevSecOps team approached me. They wanted to solve similar problem, which we solved in hackathon. They wanted to automate vulnerability exploitation. The goal to show real proof of exploitability to increase severity of found vulnerabilities, which can help them to prioritize tasks, remediation tasks. Pretty smart, right? So I tried to explain him technical details, how we implemented it, how it worked, how LLM can interact with external tools. But to be honest, our solution was very complex, a lot of moving parts, custom integrations, workaround. And it was, for me, hard to explain him. So I talked with him, I shared with him our presentation, code, and then I forgot about it and returned back to my usual stuff, Azure Cloud, Kubernetes, until a few weeks ago. So a few weeks ago, I got a message from folks at Java community. We need speakers. Would any DevOps colleagues like to share with us something? My colleague, Sergey, actually, suggested, what about speaking about MCP? And I'm like, this MCP server sounds interesting. But wait, what is MCP server? I literally had zero idea what it was. But I thought, why not to agree? So I can hit two birds with one stone, right? I can learn something new, especially related to AI, and share it with community. So I started research, reading documentation, watching videos, and then it hits me. This MCP thing, it solves exactly the problem which I had when I tried to explain my security colleague our solution. I remember that conversation where I struggled to explain him how LLM interact with external system. And MCP server, it basically answers to that problem. It's evolution and standardization of what we were building at the hackathon. The industry looked to all these custom integrations, custom implementations, and said, you know what, let's create a proper protocol for it. Let's standardize it and make it easy to understand. And suddenly, what took for me 30 minutes to explain to my colleague now has a name, MCP server. So let me share what I discovered in an intense week of deep diving to MCP. So what is MCP? Let's break down it to the way that actually makes sense. MCP stands for Model Context Protocol, but forget this fancy name for a second. Remember that I mentioned tools for LLM at Hackathon. We built custom integration, which allows LLM scrape website, execute commands, run scripts. But here's the problem. Every team, every company, every developer was building this integration in their own way. And it was like Wild West. Every company built using their own API design. They connect doing their custom integrations. And if you want to reuse their solution, good luck, because you have to rewrite half of it to make it work with your setup. MCP said, enough of this chaos. Let's create standard protocol. Think of this, and it will resonate with you as engineer. MCP is basically an API specification for AI tools to interact with external systems, just like we have REST API, GraphQL, gRPC, etc. MCP is protocol. So how it works? You have Claude or any other LLM which supports MCP. One second. Yeah. And you have your system tools which you want to expose. And in the middleware, there is MCP server. a bit later, I will show you in details how to write it. But now, so it's one thing. So beauty of it, once you build an MCP server, any client which supports this protocol can reuse it. No needs code rewriting. It just works. From DevOps perspective, think of MCP like microservices for AI. Each server exposes specific capability through standard interface. Want to give LLM access to your database, MCP server. Want to allow send emails, MCP server. Want to send message to Telegram, right, MCP server. And MCP server takes all heavy lifting on it. Authentication, message formatting, error handling, and you can just focus on implementing that stuff which you need. So instead of explaining, well, we have Python script which allows you to talk with external system, and then we wrap up it with open API, you can just tell, we have MCP server, and anybody who knows this protocol will understand you. And from my perspective, this evolution from chaos to clarity. So from custom hacks to standard protocol. And the best part that I will show you how easy to build such MCP server in a second. So let me switch to Claude. So to be honest, I'm not going to send comments again, because you know that magic with demo. On a demo, it doesn't work all the time. Something goes wrong. So in the end, I will share with you QR code with link to GitHub repository where I have everything. Generated code, prompts which I used, and different instructions how to run different tools. So you will also be able, if you're interested in it, to repeat the same. So what I did, I tried to do it 3 times with different LLMs, and it worked. So it proves that with LLM, you can build it really easy. So I sent to LLM prompt. Actually, I helped LLM a bit. So I told LLM what actually I want to avoid generation extra files, a lot of files. So I told that I need exactly 1 file. I want to use exactly this library. I want to build MCP server using Python, etc. But this part, I mean, border can be reused as a template. So what actually need to be changed? Only this part for your own MCP server. So what I told, I asked Claude to build MCP server to send Telegram messages from bot. I added link to documentation because Claude already able to scrape documentation, so it can read documentation. Based on this documentation, use system which you want. And I asked LLM to implement 2 tools, to get available chat ID and send message to specific chat ID. So it went to documentation, analyzed it, and then prepared several files. Again, I asked which files I would like to have. So I told that I want to write this code in Python, want to have requirements.txt file, file with code itself, and a README file. So it generated me requirements.txt. It contains dependencies, if you're not aware what Python is. So I created empty project, inserted what it suggested to me, copied Telegram server code, also inserted without any modification. And actually, I haven't even analyzed what it created there. And I also asked it to prepare instructions for me, what I need to run to test the server. So together with you, I can do it once again. Telegram server. I also copied it to make it easy to notes. So I created new dir, copied all files. Then I created virtual env. If you didn't know, it's virtual environment for Python projects to have all dependencies in isolated place. So I don't want to install any libraries to global folders to avoid breaking other systems. So I put everything inside my project. And then I install dependencies. MCP, by the way, MCP idea of MCP protocol, if you know that company Anthropic, they implemented it. They implemented it about 1 year ago, by the way, but only about half year ago it became popular and everybody started to use it. They also implemented great tooling for it. So they implemented SDK for different for different languages. And they also implemented tooling like Inspector, which you can use to test your MCP server. Because as I mentioned, MCP server, it's a protocol, it's already have libraries. And what is MCP server is doing, it's creating, let's say, functions which your LLM can use to do some work. And before you start to use it, of course, it will be useful to test that these functions works fine. So community industry already developed a lot of tooling for it. For example, we implemented Telegram MCP server, which allows me to get chat ID and to send a message. By the way, I forgot one thing. It's also was mentioned in documentation. I need to configure my MCP server. I need to configure a Telegram bot API. If you ever build Telegram bots, you know what is it. And no, so I need to configure it a bit. So I created environment variables with my Telegram bot token ID, token itself, and user ID. It's my user ID, so bot can send messages to me. If I list functions, by the way, I asked to generate 2 functions, but 3 times in a row, LLM told me, I know that you asked me to create 2 functions, but I think it will be more useful to have 4 functions. So we can, of course, in a border, put more strict conditions, implement only what I ask, implement only that number of functions which I asked. If you don't do this, LLM can do a lot of extra. So we can test it. Before we start use it with LLM, we can test them manually. And also, we can see how MCP protocol works under the hood. Under the hood, it uses JSON RPC, by the way. So implemented function to get info, but I'm interested in function get chat ID, because to send message to somebody, it's need to know chat ID of that person. And then I can send message. Run tool. Open a new window. Here it is. So I just sent message to me. So when I tested that this MCP server works fine, now I can use it in LLM. So you saw it generated a couple of files, requirements txt and Telegram server py. I copied them and just started. So to integrate it with any LLM which supports MCP protocol, I need to configure that tool. For example, I already prepared for myself a configuration for Cloud Desktop, and I here added command. How can I show it? So MCP configuration for Cloud Desktop located on Mac, it's located in application support, Cloud Desktop config JSON. So if I open it, you can see here that I can add multiple MCP servers. So I added this one, Telegram, and provided here comment how to run this MCP server. By the way, MCP server can use two types of protocol. If you run it locally, you can use std.io. So it just start application and like standard send message as standard input and get message as standard output. But also it supports HTTP. So I added this line. All the time when you add new MCP server, you need to restart your LLM, or how to better call it. For example, I use Cloud Desktop now. I already restarted it. It's already there, so I can immediately start use it. Example, let me open new chat. If you go to settings, you can see here that new MCP server available for me. I can enable it. Also, I can allow LLM use only specific functions, but I allow to use all of them. And then I can ask LLM to send message to me. Can you send? Oh, let's make it more complex. Can you send current weather to me? Gram. So because Cloud Desktop already, your location Uzbekistan, okay. Cloud Desktop already can go to web, so it can get current weather. Then it realizes that to send message, it needs to know chat ID, and it sees that there is available function to get chat ID. So it asked me, usually, at least till it's still new protocol, and it's more safe to validate manual that what LLM going to execute. By default, it asks permissions each time, but you can configure it to allow use tools all the time. I allow once, so it calls this function to get chat ID. It got my chat ID. Then it's Googling current weather in my location. By the way, you can see that it understood current location. Now it prepared message. It also asked me permissions to use this function. Done. And let's see. Yeah, after demo message, you can see that it sent current weather. And great thing which I mentioned, because MCP server become new standard, I can reuse exactly the same MCP server which I built not only with Cloud, but also with any LLM. Actually, I can use it with VS Code, for example, with Chat Copilot. So I don't know, it's up to you how to use it. For example, I can ask Visual Studio Code to send me last error which I have, or list of, can you send me list of open files to Telegram? I hope it's still connected. In parallel, let me open LM Studio. Oh, it's also, you can see, it asked me to run functions. Progress, pom, pom, pom. It's also found my chat ID. Allow. So it's gonna send me something. Let me see. Open files in editor. You can see it sent me currently open file and added content of this file. And as I mentioned, now I can easily to start use this MCP server in any tool. I just need to configure this MCP server, and that's it. Next thing, it wasn't planned initially as a part of my demo, but I realized that if you start have many MCP servers, what can happen? You can see such picture. So if you have a lot of MCP servers, you also need to manage a lot of different connections. But industry also trying to solve this problem. And I found good answer on this problem, which can compose all MCP servers which you use. It's Docker. Docker company works together, as I got from their documentation, they work together with Anthropic to develop what they call MCP gateway. And actually, you can already use it locally. For example, if you want to develop something, I mean, if you're going to develop not MCP server, but if you're going to solve your own problem, you already can find hundreds of existing MCP servers in Docker. And you can connect any of them with one click. Oh, by the way, we can. It already supports ability to integrate it with Cloud Desktop and a lot of different popular LLM tools. You can easily add new. Let me add something maybe. 1 second, maybe curl. I haven't tried it, but maybe we can do it together quickly. So I added new tool. Yeah, now I can use it. But Cloud Desktop, at least now, unfortunately, cannot dynamically discover new tools, so I need to restart it. Let me see if new, you don't see it. I restarted it. I already connected MCP Docker as a MCP server, and it works as a gateway. So I already configured my Telegram MCP server, added to that gateway my Telegram server, and also you just saw that I added curl. So now it's available. Let me try to use it in real life. But I'm doing it first time, so maybe it will not work. Can you curl? I don't remember that site. Oh, can you curl me? Yes, it asked me to use this curl utility. Empty response, that could mean blah, blah, blah. But it tried. So you see, there is a lot of different integrations, and you don't need to write your own custom for existing servers. But of course, you can write your MCP servers for your systems. And we're also going to discuss it. So let me return back to presentation. One feature on MCP server, but MCP is more than just tools. Let me describe all of them. And first, let me start with tools, which we just saw. So tools is just functions which are available for MCP. So it's something what LLM can call. If you want to query database, you need to develop tool. If you want to deploy something to Kubernetes, you need to create tool. If you want to send Telegram message, you know the drill. But besides that, there is also resources. Resources, these are data sources that LLM can read from. Think of it like files or endpoints which can provide context. For example, you could expose your database as a resource. You can expose your company's documentation as a resource. And what's the difference from tools? Resources are more passive. So resources, it's like something about providing information, and tools, it's actions. Next thing is prompts. Prompts, it's more interesting thing. It's pre-built prompt templates that you expose via MCP. Let's say you have a specific way you want LLM to analyze vulnerabilities. So you can package this prompt as a template in your MCP server. And users can discover it and use it without knowing right way to ask LLM to do something. It's like shipping best practices with your MCP solution. And sampling. It's much more advanced scenarios. It allows MCP server to request the LLM to generate text. Basically, your server can ask LLM to do thinking or generating something as a part of process. Think of it like callback capability. And there are MCP designed as an extensible protocol. So there are a lot of ideas which could be added in the future there. So let me summarize a bit. With MCP, now your LLM can read something, its resources. LLM can act in your system, its tools. LLM can leverage your expertise, its prompts. And LLM can collaborate with your server, its sampling. In my Telegram demo, I used only tools, but imagine that we could use resources to provide messaging history. We could use prompts to provide way to summarize my weekly discussion with somebody. And finally, let's wrap up it. So what we learned today. First, AI integration has evolved. A year and a half, we were building custom tools to interact with external systems. Now we have a standardized protocol. Second, building AI integration now is ridiculously quite easy. So you saw that I, as a DevOps engineer, could do it in 15 minutes. So I, as a not expert, could do this, and you can do this for sure too. And third, MCP, it's not just function calling, it's complete framework which supports resources, prompts, sampling, so you can build sophisticated, intelligent integration. For me, this journey was quite interesting and useful. And my challenge for you, think about your daily work, what routine task you have. Maybe you can automate deployment of something. You can automate monitoring stuff. So you can come to home and try to realize your idea with MCP, or not only with MCP, with any tool. So you can do something new and also share it with community. So it will be quite useful for each other. And that's all from my side. Thank you. So now I'm ready to answer on your questions. And if you scan this QR code, you can see link to GitHub repository with resources. I also added YouTube videos, which I learned, very interesting YouTube videos, especially there is one which I highly recommend you. It's Network Chuck video. There are a lot of videos on his channel. I highly recommend to subscribe to it. Plus, also I added link to feedback form. So if you don't mind, spend 1 minute to evaluate current presentation, maybe suggest something, what you want to hear in the future. So yeah, that's it. I can answer my questions.
Thank you, Ruslan, for presentation. My question is, can the system works continuously with incoming requests? For example, it can search for any incoming message in your Telegram chat and after translate it, for example, in English and send back translated message. So can we create this continuously working system with MCP servers?
Yes, it already supports it. There is MCP server. It's already can work with long-running connections, even with remote MCP servers. So MCP, it's not stateless; it's stateful. How to tell it? Connection. So it can connect to a remote server and not only send requests, but also get notifications from your server. So yes, it's possible to do.
Thank you.
Where it's keep the information, does it has something like, I don't know, for example, if we have too much interaction with the Telegram bot with different messages, and where these messages are collected and how the MCP or Cloud can consume all of our messages, all of our interaction, and make it proper, continuously sending the proper messages, proper answers.
LLM or MCP doesn't solve this problem instead of you, for you. They just provide ability to get this information. But how you manage your context, how you create new context in your MCP solution, it's up to you. But yes, it's a problem. I think I understand where this message came from, because to be honest, it's not everything fine with this solution. Of course not. LLM, it's a bit expensive thing. If you interact with external systems, you spend a lot of tokens, because how even this, my demo worked. For example, when I sent message about weather, so it quite expensive, because when I asked to send message to Telegram, first it only planned what it needs to do. It get list of functions from MCP server. Then actually it's not. I told all the time LLM which supports MCP. LLM doesn't support MCP itself. Client which works with LLM supports MCP server. So how it works? This Cloud desktop client, it sent message to MCP and got a request. In request, there were special keywords that LLM, to make next steps, it needs to get information from MCP server. Then this client added, so it concatenated a list of available tools to new message, which it sent to LLM. And message become bigger, because it sent not only additional message, it's like new message with all history. And each this interaction, it's sending new, bigger and bigger message each time. and you understand each time when you send message, it costs money. So, and it's up to you how to manage it, because you really cannot get all message history for 1 week. No, it will not work, because you will not have so big context. And you need maybe process something, ask LLM to summarize, and open new session with LLM and use summarized information.
Thank you.
You're welcome.
Thank you. And what about the security points in this solution? Is it security?
It's just protocol, so it's also up to you to implement authorization, authentication. So no, it's not part. It already supports authentication. So if you deploy MCP server remotely, it already supports OAuth protocols, but it's only authentication. And it's up to you on MCP server to authorize. So you see that Alexander requested, it's not an anonymous user, it's Alexander, but it's up to you to implement. But what Alexander can do on this server.
Thank you.
So you can restrict, you can implement the least privilege for specific user, right?
Yes, but again, I would like to highlight that it's like REST. REST doesn't solve this problem for you. It supports ability to send information about user, but it's up to you how you design it on your server, how to restrict access.
Okay.
I have a question also. So what about the structure of all the Telegram bots or something like this? I mean, when we just write some bot that's request for the answering for us, I mean, can we just make some big bot, like using the Telegram IDs, chat IDs, and can we just make the all like big difficult structure with this?
With this, what are you asking about?
I mean, with cloud, like, can we make the big structure of Telegram users?
So it's not question about MCP, right? It's question about LLM, and can we do this?
Yeah.
Yes, it's already supports. So maybe you heard about the term vibe coding, about tools like, I don't use a Cursor. I don't use it actually because we don't have licenses on my project, so I can buy it for myself, for my hobby projects if I want, but I already buy Claude Desktop. I can also use Claude Code. I already tried to build small projects. Yes, it can. By the way, about 1 year ago, I also participated in coding battle. and I tried internal solution which we developed in EPAM. So I tried, what if I try to build a bot to, I participated in, so to give you more context, I participated in challenge which called Code Battle. We create bots which then fight with each other. So I thought, what if I fed it as input documentation to how this bot should behave and ask to build it for myself. Because I was lazy, I didn't want to spend a lot of time to learn it, and I successfully did it. So yes, now LLM, by the way, all this presentation I did with LLM, it's not created instead of me, but it helped me a lot to generate text, to generate this text. So first of all, I developed everything in Russian. Then I tried to, I asked LLM to translate it for me. Then I asked to split to different slides, make it more fun, and generate this text for me. So it did this job well. Also, this diagrams, it's also MCP generated based on my text.
Okay, thank you.
Next question.
So, well, thank you. Thank you all. Спасибо.